We want to solve this absolute value inequality, which is the absolute value of x minus 3, close the absolute value, and greater than 2. An absolute value set of brackets like this means that whatever answer you get from inside of this, it's going to come out positive. Even if it's really negative, it's going to come out positive. So with that, that means you have to have two different possibilities for this inequality. The first one is x minus 3 greater than 2. And notice that's the way it's written without the brackets. But the other one that you must also solve is x minus 3, but flip the inequality sign and change the sign of the number out on the right. Once you do that, you have to go back through and solve both inequalities. So on the left, you'll have x greater than 2 plus 3, which is x greater than 5. On the right side, we have x less than negative 2 plus 3, and that would be x less than 1. So go through and graph those on a number line. You need a positive. This should be a 1 and a 5, so we'll put 0 here and do 1, 2, 3, 4, 5. And those are open dots on each of them. So we have to do the first one here, which is x greater than 5, and it's going to go up and over this way. The other one is x less than 1, and it's going to go back this way. It's a good idea on absolute value inequalities to check your solution areas before you graph. So check all three different possibilities. This is 1, this is 2, and this is 3. Check all three areas. Choose 0 from this area. If I put a 0 in for x and subtract 3, I get a negative 3. What is the absolute value of negative 3? 3. Is 3 greater than 2? Yeah, so if it's true, then you're going to shade it in. Over here, let's choose 3 and put it in. If I put a 3 in for x and then subtract 3, I get a 0. The absolute value of 0 is 0. Is 0 greater than 2? No. So let's go over to the other area. Let's choose 6 from this area. If I put 6 in for x and subtract 3, I get 3. The absolute value of 3 is 3. Is 3 greater than 2? Yes, so you shade it in. The reason why we need to check these with absolute values before we just blindly shade them in is because some of these may actually have all three areas shaded in. Some may only have the middle. Some may have none at all. To solve this absolute value inequality, you must write it the way it appears but without the brackets. So x plus 8 less than 6. But then also write x plus 8, flip the inequality sign to greater than, and change the sign of the number on the right. Solve both of them. On the left, it's x less than 6 minus 8, which is x less than negative 2. And on the right, that is going to be x greater than negative 6 minus 8, which is a negative 14 on the right. So x greater than a negative 14. If you go to the number line and find negative 2 and negative 14, here's 0, there's negative 2, and then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, negative 14. These are both open dots. X less than negative 2 would go up and over this way. And x greater than negative 14 would go this way. So check your areas. Let's choose one that's off to the right here. If I put 0 in from the outside right, 0 plus 8 is 8. The absolute value of 8 is 8. Is 8 less than 6? No. So we don't shade that in. Pick one from the middle here, like a negative 10. Negative 10 plus 8 is negative 2. The absolute value of negative 2 is 2. Is 2 less than 6? Yes, so we're going to shade that in. Pick one from the left-hand side, like a negative 15. Negative 15 plus 8 is negative 7. The absolute value is 7. Is 7 less than 6? No, so we don't shade it in. So this is your solution. To solve this absolute value inequality, you would have to write it as it appears first, but without the brackets. And then you're going to write it as x plus 1 less than negative 10. Flip the inequality sign and change the sign of the number on the right. Solve both of these. X greater than 10 minus 1, which is going to be x greater than 9. And then on the right side, x less than negative 10 minus 1, which is x less than negative 11. So we have to go to the number line here. And we need a negative 11 and a positive 9. So this will be 1, 2, 3, 4, 5, 6, 7, 8, positive 9. And then for negative 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 11. Open dots. And x greater than 9 is going to go this way. And x less than negative 11 is going to go that way. So check out the three different areas. In the middle here, if you put a 0 in, up here you'll get back a 1. 0 plus 1 is 1, absolute value is 1. 1 is not greater than 10, so this will not work out. Over here, if I choose 10 from this side, 10 plus 11, or 10 plus 1 is 11. Absolute value is 11, and it is greater than 10, so you'll have that. And then over here on this side, choose a negative 12 to come up with. Negative 12 plus 1 is negative 11. Absolute value is 11, which will be greater than 10, so that is true. Here is your solution here on the graph. This is a special case, and this is the absolute value of x plus 4. Close that absolute value, and greater than negative 3. Don't just start working the problem. Look at the problem as a whole and understand what it's asking of you. You have the absolute value of x plus 4. Anytime I have an absolute value, no matter what number I put in, no matter what expression is inside, the answer will always come out with what sign? Positive. So I'm going to get a positive number on this left-hand side no matter what. How many positive numbers can you give me that are greater than negative 3? A lot. Almost all of them, yes? All positive numbers will be greater than negative 3. So I'm going to do the work on this and show you what would happen if you worked it out. And so that when you see this scenario later on, you'll understand what happened. So x plus 4 greater than negative 3 and x plus 4 less than positive 3. If I solve it, I get x greater than negative 3 minus 4, which is a negative 7. And then on the right side, x less than 3 minus 4 comes out to be a negative 1. If I do it on a number line, I need a negative 1 and a 7. So here's 0, negative 1, 2, 3, 4, 5, 6, and then 7. So there's a negative 7. So we'll go open dot, and look what happens. It goes this way, and it goes this way. But now go to check it and see what happens. So we will have, well, let's pick a number from over here. We'll pick 2. We'll pick 2 because it's clearly on this side. Actually, it should have been right here, right? Yeah, that's my fault. We'll pick 0. So we'll pick 0 like he said. And if we put 0 in here, you get back a 4. 4 is greater than negative 3. So look what happens. You're shading in an outside area. Go inside and choose negative 2. Negative 2 plus 4 is 2. Absolute value is 2. Is 2 greater than negative 3? 2 is greater than negative 3. And then on the left-hand side, if you choose a negative 8 plus 4, that's negative 4. Absolute value is 4. 4 is greater than negative 3. So anytime you see a scenario where you have the absolute value expression, and that's all that is on the left-hand side, and it's greater than a negative number, your answer can automatically be all real numbers. This is a special case in which we have the absolute value of negative x plus 6, and then close that value and have less than negative 2. So think about what's coming out here. You have an absolute value, and that's all that you have on the left. The solution to that left side must be positive. How many positive numbers can you come up with that are less than negative 2? None. There are no positive numbers that are less than negative 2. So watch what happens when this gets worked out. So you have negative x plus 6 less than negative 2 and negative x plus 6 greater than 2. On the left, it's negative x less than negative 2 minus 6, which would be a negative 8. Flip the sign because you're dividing by a negative 1. And then on the right, negative x greater than 2 minus 6, which would be a negative 4, but divide by the negative 1 to get x less than 4. So go here on the number line and find 4 and 8. Here's 0, 1, 2, 3, 4, and then 5, 6, 7, 8. Greater than 8, less than 4. But go through and actually check each one of these. Choose 0 for this side. If I put a 0 in here, I come back with a 6, and it's not less than negative 2. If I go here and choose a 5, I come back with a 1, and it's not less than negative 2. And if I choose a 10 here, I come back with a negative 4, which turns into a positive 4. It's not less than negative 2, so there is nothing there. That would be no real solution. To solve this, you're going to set it up as it appears without the absolute value brackets, and then write it as 2x minus 2 greater than a negative 12. On the left, you'll have 2x less than 12 plus 2, which is 14, and then divide the 14 by 2 to come up with a 7, so x less than 7. On the right hand side, you'll have 2x greater than negative 12 plus 2, and that's going to be a negative 10 on the right side. You have to divide by 2 to come up with x greater than negative 5. On the number line, you need a negative 5 and a positive 7. So we'll go 1, 2, 3, 4, 5, negative, and then 1, 2, 3, 4, 5, 6, 7. X greater than negative 5 is going to be here, and then x less than 7 is going to go in the other direction. Let's check it out. We'll plug in a 0 here. I'll get back a positive 2, which is less than 12. So, yes, this will work out in this area. And on the right-hand side, if I put in an 8, I'll get back a 14, which is not true. And back here, if I put in a negative 6, I'll get back a 14, which is not true. So this is your solution.